take a look at number 26 in 5.7. We want to use the change of variables formula to evaluate the following definite integral. So remember what we're doing there is we're going to do a substitution. And of course, we're going to transform. If I choose u to be my substitution variable, I'm going to transform this integral into the u variable. I'm going to also change the limits of integration and then evaluate that with the fundamental theorem of calculus part 1. Now, how would you evaluate this integral? It's not an antiderivative that we immediately recognize. I don't really see a composition. Sometimes when we have a fraction, we choose u to be the denominator. That would not be good to choose u equals x, right? If I choose u equal x, du is dx, and I don't change anything really in this integral. So what if I choose u to be the natural log of x? Because when I choose u to be the natural log of x, the derivative of natural log of x is 1 over x, right? So du would be 1 over x dx. And look here, we've got 10 over x dx. So if I multiply both sides of this by 10, 10 du is 10 over x dx. So that's going to work. I do need to change limits. The x limit of 1 becomes what? U will become what? Natural log of 1. Well, natural log of 1 is 0. And then if x is e to the 8th power, the u would be what? Natural log of e to the 8th is just 8, right? And so the integral will change from 1 to e to the 8th to 0 to 8. And I'll have the 10 divided by x dx. That's the 10 du. So I pull that 10 out, and there's my du. And all that I have left is natural log of x, which is u. And so this integral is, from here, now much easier. What's the antiderivative of u? Just by the power rule, it's 1/2 u squared. 1/2 of 10 is 5. Factor that 5 out, evaluate u squared at 8 and at 0. And of course, I get 64 times 5, or 320. So pretty easy one once we get the substitution done correctly. But I hope this is helpful on this one. If not, let me know.